Scopus, ABDC, ABC, Q1, Q2, Web of Science, and ABS Index journals. She has also authored 9 books, contributed various case studies to Taylor and Francis and Routledge, and chaired several international conferences and FDPs. She has also being judged for globally renowned health prizes at the United Nations, and has guided numerous PhD scholars, and is a resource person for research and analytical softwares also. Her contribution has also been recognized with significant honors, including the Research Excellence Award 2024 and Guru Vandana Samman 2025. So, ma'am, we are truly honored to have you with us today. And thank you, ma'am, for joining us. We are eagerly looking forward for your insights on Smart PLS and structural model coefficient modeling. So over to you, ma'am.
Thank you so much, Garima ma'am, for that introduction, beautiful introduction. Thank you so much. Very good evening to one and all. I'll be talking today about the Smart PLS. Can I have this right of sharing the screen, please?
Yes, please go ahead.
Sure. Ma'am, is this slide visible to everybody?
Yes, yes.
All right. Okay. So once again, a very good evening to one and all. I'm Dr. Sneha Rajput. I'm talking about the Smart PLS handshake. That means the introductory session on the Smart PLS software. Let us start. First, I would like to highlight what all we will be covering in the Smart PLS session today. As it's a 1 hour session, I would ensure that I give an overview about.
Ma'am, sorry for inconvenience. Your mic is not, working well.
Ma'am, you are on mute.
Is it there now?
Ma'am, presentation has been ended. Can you please share again?
Yeah, 1 second. Is it there, ma'am, now?
Yes, ma'am.
All right. If anything is like missing, ma'am, please do let me know in between also.
Sure,
so that
ma'am.
there's no break in the flow. Okay, so we'll start with the session now. Before I start with the basics of Smart PLS, I would like to just tell you what all we will be covering in today's session. Like first, I will be talking about the reflective and formative models. Then slowly we'll go on to the zero order model, first order, second order models in the Smart PLS. Then I will be talking about what kind of variables that we are using in Smart PLS, that is exogenous, endogenous, mediating and moderating variables. Coming to the measurement models and structural models, then inner model and outer models, outer loads and outer weights. And I will be also highlighting how the PLS is different and we have a benefit of PLS over MOS. And then directly we'll go on to the hands-on PLS and we will be calculating the various statistics associated with the Smart PLS. Right. So let us see what is a reflective and a formative model first. As you can see on your screen that there are two variables. There are two figures that you can see. One is CSR, which is reflecting certain rays towards the yellow boxes you can see. So when the construct leads to certain statements or certain causes, that is a reflective theory. I have mentioned there also the construct causes certain indicator variables, or the construct is the main cause for various elements that are present in the construct. Like for example, CSR, And in the second model, we can see here that the various statements are causing one variable. The measures are the reasons behind the formation of a construct. That means that is a formative model, right? So reflective model as well as there are two kinds of model that we are going to study in the Smart PLS. And let me tell you, Smart PLS can handle both the models very easily, very beautifully. Whereas when you talk about MOS may not incorporate formative models, only the reflective models are used in MOS. So this is one advantage that why we are using the Smart PLS, because we can have both kind of models in the Smart PLS, right? Second, uh, the most difficult part in Smart PLS is to identify whether the model is reflective or whether the model is formative. So for this, basically, if you see, we have three options present with us from which we can identify whether the construct specifically is reflective or it is formative. When I say construct, that means it is a variable, right? When I say the statements, they are the measures of that particular construct. So let us not interchange the words again and again so that the consistency is there. I will be talking about the constructs in the entire session. I will be taking construct as a variable, as a synonym of variable in the entire session. Right. So first thing that will help you to identify whether the construct is formative or reflective, you can use the theory, that is the review of literature. Then second is the basic understanding of the construct. I mean, we have to also sometimes use our common sense to understand whether the construct is causing certain effects or effects are causing certain constructs. So this is another understanding between the relationship is also very important. And the last, in case both the things are not working, in case you do not get anything in the review of literature, or sometimes it is also happening that the the model can be both reflective as well as formative. The like smoking can cause stress, sometimes stress can also lead to smoking. So this is how one construct can also create certain measures, and sometimes measures can also create a particular variable or construct, right? So in that case, if it is not clear to you that the construct is reflective or formative, then we can use a CTA, that is a confirmatory tetrad analysis, that I'm going to take over in the session. Meanwhile, in a short while, I will be talking about the confirmatory tetrad analysis also. Okay. Then coming to the zero order model. As I said, in Smart PLS, we can have zero order, first order, and second order model. If you talk about MOS does not handle the lot of complicated model. Lot of complications cannot be handled in MOS. MOS is simply working on the first order model. So when we talk about the use of PLS, PLS can incorporate all three models together in its mechanism, right? So first is zero order that you can see on your screen. Just have a look. You can see there is just one construct, and there are four statements, or there are the four measures associated with the construct. So this is a zero order. We have just one construct and uske चार statement हमारे पास हैं. That is a zero order. Now, when I say a first order model, that means we have many zero order models connected to the one basic zero order model. Right? You can see here there are four independent constructs, and they are all four connected to one dependent construct. But basically, if you see, you will see that all five are a zero model. So when we connect some zero order model as independent to one zero order model as dependent, it becomes a first order model. Second. Right. Now coming to the second order model. Now here, and when you compare this second order with the previous one that I have just taught, first order, you will find that in the second order, we can have multiple dependents. But in the first order, there was only one dependent variable or one dependent construct. So it is very clear that second order can have multiple dependent constructs and multiple independent construct. And in second order, it is very clear that if one construct is right now working as a dependent, maybe when you connect it with another dependent, it can become the independent, or it can become the mediating or moderating. So second order is the most complicated form of the PLS model that we apply in Smart PLS. Am I clear till here to everybody? What is the zero order?
Ma'am, in chat box there is a question that what do you mean by factor in this?
What do you mean by the factor? Actually,
Yes.
the if you see that for example, social media, word of mouth, they become the factor when we connect them to a particular dependent model. I mean, one variable can have multiple factors also, right? Agar social media ki, if you talk about social media itself is a construct. It can have sub factors into it. Like social media's visibility can be a factor, social media, influencer can be a factor. When there are sub factors, they are sub construct in a construct, they become the factors. And again, in those factors we can have more statements, right? Is it clear? Shall I
Can
go
I
ahead?
ask a question, ma'am?
Yeah, please,
Can I
please.
ask, ma'am? Yeah,
Yeah,
yeah. Ma'am, basically, construct is a latent variable, as you say right now. Ma'am. Construct.
yeah, yeah,
Yeah, latent variable. And
yeah.
a list of manifest variables would be measuring a latent construct.
Measuring that particular construct, yes.
Yes, ma'am.
So
Factor
I
in
have
that
already
sense, actually.
mentioned.
Yeah.
So we can have all the questions in the end, so that I just go with the flow, and I will be also talking about
Yes,
the
ma'am.
latent variables and the manifest variables, right? So I know
Yes,
some
ma'am.
people must be aware about the Smart PLS, and some people are very new to the Smart PLS. So let us cooperate,
Yes, ma'am.
those who are
I'm new to
learning the
that.
Smart
Yes,
PLS.
ma'am.
Yeah, yeah. So let us
Yes.
cooperate with the new learners, so that they are learning for the
Yes.
first time. So let us understand each concept slowly and gradually, right? Coming to
Yeah,
the
yes.
exogenous and endogenous variables now. Right. So if you see here, the independent, generally when we call them as independent variable, they are exogenous variables like e-word of mouth and social media influence. They are influencing the buying intention. So here the one who is causing the influence is exogenous, and one who is getting influenced or by the exogenous variable becomes the endogenous variable. Right here. Now, if you talk about the mediating variable, so these are the basic concepts of one should know that what are mediating variables, what is a moderating variable. Sometimes it is very confusing. People are oftenly, interchanging mediating and moderating. The mediating variable is found within the model, and the the dependent constructs are influencing the independent constructs are influencing the dependent construct via mediating variable. That means it is present inside the model. Okay. And then coming to the moderating variable, when the construct is present outside the model, but again it is influencing the relationship between the independent construct and the dependent construct. And in Smart PLS, we have a special, mechanism to evaluate the impact of moderating variable. If you're using Smart PLS version 3 also, in that case also, the mediation effect is we can measure through the models, but the moderating effect is already there. We can add on any variable as a moderating variable, and there is a separate calculation facility provided in the Smart PLS. So this is also one advantage that we can see in the Smart PLS over the MOS. Now, coming to the measurement model, what are the measurement models? So when we are talking about the statistics related to the measures या factors sometimes, जिसको हम factor भी बोलते हैं, factor के अंदर और statements हो सकते हैं, right? So here right now, to make it more simple, I have used directly the statements in one construct. That is, there are 4 statements present in e-word of mouth. So when I am going to calculate the statistics associated with the statements or the measures, then it will be a measurement model. And when I'm going to identify the relationship between the construct, that means how much impact of e-word of mouth is on buying intention, or how much influence social media is having on buying intention. When I'm studying these relationship, then it becomes the structural model, and it is also known as sometimes inner model, and the measurement model is also known as the outer model. So this is we have to keep in mind, because we have to see number of other statistics when we are evaluating the model. So again, let us see what are the outer loads and outer weights. When do we call them outer weights and when do we call them the outer loads? So in case of a reflective construct, if you can see on the screen, the reflective constructs, the significance value or the p value we or the average the standard regression weight we generally of formative construct, we call them as the outer weights. So let us not get confused.
Sorry to interrupt. Please, sorry to interrupt, ma'am. Please repeat the last line as your voice was there was some voice breakage.
Sure. See, I'm going to repeat once again the entire concept of outer weights and the outer loads. When your model is a reflective construct, yeah, when the please, can you please mute? Yes. So when the model is a reflective model, in that case, the standard regression weights will be known as outer loads. And when the model is a formative construct, the regression weights, the standard regression weights will be known as outer weights. So in this particular, if you can see, I have mentioned both the arrows. You can see some models, some zero order models are reflective and some are formative. So in that case, we can identify when to call, when to check the loads and when to check the weights. Now, if you see in this particular model, you can identify there are many zero models that we have connected. Can somebody please tell me which model will have the outer weights? Anybody can write it in the chat also. Which particular model will have the weights? Yeah, I'm making it full screen. Is it visible now? Yeah. So if you see again, so we have combined model here. Is it visible to everybody? There it is. I think there is some problem with the.
No, ma'am. PPT's slides are visible.
Acha, it is there. Okay. So I think it is showing the slide of exogenous and endogenous variables
Yes,
still.
ma'am.
Because
Yes.
I put it on a mediating variable I've already discussed. This is the moderating variable that I've already discussed. This is the combined model we can have in Smart PLS. This is the one advantage that we have seen over the of Smart PLS over MOS. Here we can see the measurement model and the structural model that I've already discussed. That structural model is also known as the inner model. I'm just repeating for the sake of understanding more. Right. Then we were discussing the outer loads and the outer weights. You can just have a look on the screen that there are certain zero models which are connected to each other, right, as independent and dependent. And in case of reflective constructs, we have outer weights, and in case of formative constructs, we have outer. In case of reflective construct, we have outer loads, and in case of formative construct, we have outer weights. Now, in this particular, I was asking a question that which particular zero model will have the outer weights. So anything that is a formative, you can see here the previous slide will have the outer weights, and anything that is a reflective will have the loads. I think it is clear to everybody. Okay. Now coming to the MOS versus PLS. It is a very prominent question. Every scholar is always confused with, whether to use MOS, whether to use PLS, and people will have various opinions related to MOS and PLS. Reason being, the one who is using MOS is more comfortable using MOS. But I, as a person, if I talk personally, I have learned both MOS also and the PLS also. And what I found was MOS was very one mistake that you do in MOS, you have to create the entire model again and again. Even a small dot, if you create by mistake, it will consider that small dot as a construct. So we have to understand here that PLS is very flexible, user friendly. And nowadays people are accepting PLS because less of calculation is involved in PLS, and all the tables, reliability, and then discriminant validity is automatically connected in the MOS. So let us see the basic difference again between MOS and PLS. We have certain logical differences. First of all, let me just show you the first interface difference that is there in MOS and PLS. I will tell you just a small instance. There was a PhD scholar who has created the proposed model in MOS, and then she has applied PLS. So in this case, there was a very intelligent question asked from the panel, that have you used both the softwares? So she said, no, I've used PLS. Then the panel asked, why have you applied MOS in making even your proposed model? So understand the interface that you see on the screen. If whatever you see on the screen right now, these colors, these figure visibilities, they are the identity of such softwares. If I see a blue and yellow software, yellow kind of a diagram, it is obvious that I'm using a PLS. And when I see this gray and black figure kind of, so it is understood that I'm using MOS. So it is a recommendation from my side also, whenever you're making even a proposed model, try to use one software. That if you're making the entire thesis on your MOS, try to use the MOS everywhere. Do not try to make the proposed model or any figure using the various softwares in the same research work. Right. So this is all about the interface that you see. And even you can see some error terms applied on the dependent variable in the MOS, whereas the PLS is taking care of these error terms automatically. So you need not to apply extra error term on the dependent variable. So this is also this is also one good advantage that you can see in PLS. And as I said, PLS is very, very flexible, and the calculation part is very easy to understand. I will be talking about the calculation part also. Let us compare both MOS and the PLS. Take sample size in MOS, and a small sample size will also work in the PLS. Right. So understand here, the MOS does not work on a very small sample size, and PLS is very robust, and it can work with a small sample size. You need not to have a normally distributed sample size is present Smart PLS. Now, as I said, PLS will be talking about both formative as well as the reflective model. That means you can have the combination of both kind of models in PLS, whereas MOS is very talk the formative model. Only the reflective models will be working and in the MOS. Right. Then establishing reliability and the calculation of validity hypothesis testing is step by step, and you will get all the Excel tables prepared. You just have to export the Excel and your job is done. So I think it saves a lot of and it is very easy to interpret and to copy paste that particular data in the your thesis or any manuscript that you're working. Right. Then talking about the demographic variables or the grouping variables or the categorical variables. So PLS has a provision of identifying the impact of demographic variables also on the main dependents and independent constructs. Then, as I said, mediation moderation, we have options present. मीडिएशन के लिए तो कुछ अलग से करना ही नहीं है, आपको सिर्फ एक वाया एक कनेक्ट करना है दो वेरिएबल्स को तीसरे के साथ. एंड मॉडरेशन इज आल्सो वेरी सिंपल. देयर इज अ स्मॉल method that you have to apply, and your moderation result and your moderation model is also visible and it is ready to handle. Then as I've said that PLS can handle different order models in one go. You don't have to create various steps for mediation के लिए अलग, moderation के लिए अलग, या complex models अलग. No, वन गो में आप पूरा एक साथ आप जो है PLS के लिए bootstrapping कर सकते हैं. That is the best part of PLS. As I said, if you're writing a manuscript, try to use PLS. As personally, I've used both the softwares from the day I've started learning PLS, and I've learned PLS. I think I have not gone back to MOS. So, and there are a number of steps that are very difficult. For example, if I want to calculate the common method biasness, So in that case also the MOS has a very difficult procedure, whereas in Smart PLS you can before applying the Smart PLS you can calculate the CMB using SPSS also. And now another very critical this advantage of PLS is it can work with a single statement. Now what is the single statement? Single statement means, for example, in the due course of fitting the model, हो सकता है आपके पास एक कंस्ट्रक्ट के अंदर 4 स्टेटमेंट्स थे एंड 4 स्टेटमेंट्स में से आपके कुछ स्टेटमेंट्स की रिग्रेशन वेट जो था स्टैंडर्ड रिग्रेशन वेट वो कम आ जाता है और किसी एक स्टेटमेंट का रिग्रेशन वेट it's acceptable, right? So in that case, you can drop 3 statements and you can keep one statement in your one construct. Whereas when you talk about MOS, it is absolutely not possible. अगर आपके पास एक ही स्टेटमेंट बचा है तो अनफॉर्चुनेटली यू हैव टू ड्रॉप द एंटायर कंस्ट्रक्ट. आपका पूरा जो कॉन्सेप्चुअल फ्रेमवर्क था, आपका जो प्रपोज मॉडल था, वही चेंज हो जाता है. सो MOS कैन नॉट वर्क विद द सिंगल स्टेटमेंट, राइट? Now, if you talk about the interface of the Smart PLS, now you can see this is how your Smart PLS software look. Now we have various versions of Smart PLS, so maybe the interface can change. But I'm very much comfortable using PLS 3, which is from long back I'm using. So it is very much user friendly also. So I've never changed it. And another reason of not changing the software is the moment I download the new version, this automatically gets lapsed. So I am not replacing this with any of the new versions. And this is more, understanding. When it comes to understanding, this is more comfortable to the users. So this is the first interface that you will see on the for the Smart PLS. Now let us see how to proceed with the Smart PLS. First, please, it is a basic. It is not Smart PLS or it is not MOS. It is the basic for any research that the data need cleaned. And understand here that before we start with any data, absolutely you have to clear all the outliers. That means anybody who has not responded your the questionnaire very seriously, please remove that particular respondent from your entire respondent sheet. Now how you can remove the outlier? There is a method in SPSS. You can use that method in SPSS. There is a specific step that you can apply for removing the outliers. Stem and leaf diagram के through आप उसे apply करके, and you can identify which respondent number is causing trouble to your entire data. Now I will tell you why removing the outliers is important. हो सकता है कि किसी ने बिना देखे blindly they have filled responses at 555 or 111. Generally in India we do not get paid incentive for filling any questionnaire. So we are likely to take, everyone is likely to take the responses, the questionnaire very casually and not very seriously. So that can cause the low quality data. So if you're applying the low quality data, and generally your results will also be of low quality, तो हम चाहते हैं कि ऐसे जितने भी outliers हैं आप उन्हें ढूंढ के अपने डेटा में से क्लीन कर दीजिए. Second is maybe the outlier is not there, but the responses are not showing any deviation. हो सकता है कि वो इंटेंशनली ऐसे ही भरा गया हो कि सारे रिस्पॉन्सेस का जो आंसर है वो 5 है, सबका 3 है या सबका ही 1 है. So when there is no deviation, that respondent is very harmful, very dangerous. We need to remove any respondent which is not showing any deviation. कि अगर हमने कोई क्वेश्चन है भरा है, so obviously there has to be some deviation at least. कहीं 4 होता, कहीं 3 होता, कहीं 5 होता, but how is it possible that all the responses are 5? So in this case, you have to apply the standard deviation. Again, you can use Excel. It is very easy. And if you want to find out the missing value, I will show it is present inside the PLS software only. So you need not to go to even StatsWiki. Then we will be checking the, before starting with the basic of Smart PLS, please apply CMB, that is common method biasness, whether the data has got any biasness or not. There are number of biasness present in any data. If you pick up the theory, if you take up any book, they will show you how many kinds of biasness can be there. So there is a method of Herman single factor method. In SPSS you can apply. If the value of this factor, single factor, is less than 50%, then there is no biasness present in the data. So this is another session, right? The calculation of common method biasness, I will share a small video on it. It is a very 5 minutes job. सो आप कोई भी इसे SPSS पे लगा करके यूज करके मेथड कॉमन मेथड बायसनेस में CMB आप आइडेंटिफाई कर सकते हैं. आई विल शेयर अ स्मॉल just 2 minutes, it's a 2-3 minutes video it is there. I will share with the organizers. So I'm not taking up it here right now, just to save the time. Now let us see one by one what are the basic interface, how many steps are there to calculate the measurement model and the structural model. Right. First thing, we have to remember that PLS is not working on any normal Excel. We have to make a CSV data file, that is the comma delimited file. CSV file has to be there. Otherwise, the software will not read your data. Right. So let us see. And then we have to understand these are the various options that are there in the calculation part. If you see the entire list, you can see a PLS algorithm, consistent PLS algorithm. अब इन दोनों के बीच में क्या difference है? I mean, it is very confusing what to apply when. So I'm going to talk about in just next slide when you have to apply PLS algorithm and when you have to apply the consistent PLS algorithm. If you are checking a normal hypothesis, you can use a normal bootstrapping generally because it is a initial session of your Smart PLS. Avoid using complicated methods. Just try to apply simple bootstrapping to understand how the relationships are studied. Right? Then CTA, that is confirmatory tetrahedron analysis, that is to identify whether the model is reflective or whether the model is formative. And very important tool that PLS offers is IPMA analysis, that is important performance map analysis. I am telling you, one complete paper can be written using IPMA. And when you have to apply IPMA, for example, you have applied regression analysis and all your variables are showing, significant impact on the dependent construct. In that case, I want to identify ki out of 4, all are significant, but which is most important and which is highly performing. It's a small matrix. So IPMA analysis is a different tool, but very, very crucial nowadays. People are applying IPMA analysis. So let us see. PLS algorithm we will be applying when you have only the formative models, right? Then consistent PLS algorithm when you have both reflective and formative model. Bootstrapping is just basically testing the hypothesis and consistent bootstrapping when you want to check more, options present in the hypothesis relationship. So then you can apply that. But generally, initially, first step, you try applying the basic bootstrapping. Blindfold, some data points are automatically removed by the software and then they are going to check the relationship. Then confirmatory tetrahedron analysis, I've already talked about it. I've talked about IPMA analysis. Just to know कि अगर सारे की सारे variable significant है तो what is the, how will I write the result? So in that case, and there is no deviation even in the significance value. सभी का 0 से नीचे आ गया significance level. So when it is 0% to 0.1%, you have to apply IPMA analysis to identify which variable out of 4 significant variable is the most important and highly performing. And then PLS predict. I'm not able to see the screen, one second. Prediction of models on some unused data that can also be seen later on. Now, coming to the result outputs. You can see here. Let us see the scale validation. What all is present when you apply PLS. So we will have construct reliability, we will have discriminant reliability, and collinear VIF effects, outer loadings, then R square, what is the impact of independent on dependent construct. When you have multiple independent and dependent, then you can have the adjusted R square value and the model fit values, whether the entire model fits in the statistics, parameters or not. So these are the basic things that we are going to undertake. I am just shifting to a new window where I'm going to show you how we can, put data in the PLS, how to run the PLS. I think I'm clear till here to everybody. Shall I go with this? Okay. So I'm just stopping this particular screen. I'm sharing a new screen with all. Is the PLS interface is
Yes,
visible
ma'am.
to all?
Yes, ma'am. The screen is visible now.
All right, all right. Now let us start one by one. I will repeat all the steps slowly, and again and again. I'm going to repeat all the step 2 times. Just pay attention. Whatever I'm clicking here, you have to pay attention to that. Okay. Before we have to start with a new project. And before we start with the new project, you have to understand that I've already said you have to create a CSV file. I am so sorry, I cannot show you right now how to create a CSV file. But understand here that CSV file if अगर आप नहीं बनाएंगे तो आपका जो PLS है वो data pick नहीं करेगा. So I will show you how to insert the PLS CSV file. Just click on new project. You can name this project the way you want. You can just, for example, I am making it like workshop 2411. Okay. So here, your entire screen is divided into various quadrants you can see. Right. If you see the left upper side, you will see that I have added just a new project here, workshop 2411. Right. The left lower side will show you the Excel sheet that I'm going to upload slowly. I'm not going to the second quadrant first. Let us just stay on the first quadrant. I have just made, a new project and named it as workshop 2411. Now it says you can read here, double click to import the data. So I'm just clicking it. So I have a worksheet ready for Smart PLS. तो जहां पर भी आपने सेव करा है आप उसको बस डबल क्लिक करेंगे और आपका जो डेटा है वो ऑटोमेटिकली ओके करके आपकी स्क्रीन के सामने आ जाएगा. राइट. सो इफ यू सी द राइट साइड window, the entire window is showing your data. Right. You need not to understand all the things here. Mean hai, median hai, right? Minimum, maximum, standard deviation also you can check here. If something like any statement has got a very low deviation, you can remove. You actually don't remove the entire statement. Better go and remove the respondent in the Excel. So let us not talk about standard deviation right now here. Missing is अगर पूरे डेटा शीट में कहीं पर भी किसी भी स्टेटमेंट में किसी भी वेरिएबल में मिसिंग वैल्यू होगा तो इट विल बी विजिबल ऑन योर स्क्रीन. So again, you can go back to the Excel sheet and then you can upload after removing that particular missing value. यहाँ तक clear है how I've uploaded the data in the PLS, everybody? I am showing that CSV data. 1 second, I will show you. Let me just cross this. I'm not saving it again. 1 second. I'm exiting from this particular screen. 1 second, I'll show you. I think this Excel sheet is visible to all now. 1 second. See, this is the Excel sheet, right? Now, simply you just have to click on the file here. I think please pay attention on the cursor. Right, when you save it, right, just save it as a CSV file. This is here, CSV comma delimited file. I'm not saving it because otherwise it will create a replicated copy and you will have a lot of confusion. So आपको सिर्फ एक normal Excel को जाकर के CSV में save करना है and click on save. That's it. And your normal Excel is converted into a CSV file, right? This is how you create a CSV file, and I'm showing you the CSV file also right now. How it looks. You won't be able to identify only the at the home screen you will be able to see whether the file is a CSV or it is a normal Excel file. I'm just showing you the folder. I will share the folder. See, if you're able to see the screen right now, it will just fraction of seconds. right? You can see here two Excel sheets. One is workshop data Excel sheet and workshop data 2. You can just see the formatting differences of both the files. And this one is a comma. When it is a comma separated file, it will mention a comma. That means it is a CSV file. Automatically you'll understand it is a CSV file, right? I hope it is clear to everybody. जैसे आपका CSV में चेंज हो जाएगा वैसे ही उसका फॉर्मेटिंग सामने आपको उसका इंटरफेस दिखना अलग से एक फाइल दिखना शुरू हो जाएगा. और बहुत अच्छी बात है जब PLS पर आप जाएंगे तो आपको ऑटोमेटिकली वो कोई और फाइल रीड ही नहीं करने देगा. इट विल बी ओनली एबल टू रीड ओनली द CSV फाइल. Okay, I'm just stopping this share. One second. Okay, going back to the PLS now. I will be sharing my PLS screen and I will show you how the PLS will read only the CSV file. आपको बाकी चीजों का you don't have to worry. PLS will take care of itself कि उसे क्या read करना है. वो कोई और फाइल देखेगा ही नहीं सिवाय CSV के. One second, I'm just opening it. Mm-hmm. Once again, it is taking it takes some time because I've closed it. So it will just take two minutes. So now it is ready to work. Again, I'm sharing the screen. Yes, I think it is now. It will come in just a second. This was the interface we have already seen earlier. Now let us see once again. I have shown you how to create a CSV file, how to convert a normal Excel into. Let us see how to make a new project again. I'm just repeating this step. Make a new project, name it workshop. क्योंकि मैंने इसके पहले 24/11 के नाम से ऑलरेडी एक वर्कशॉप क्रिएट कर रखा था. So it will tell me that it is already existing. So I will create it as 25, right? Now, double click to import the data. As I said, automatically wherever you have saved the data, PLS will go and it will capture the data. So I've clicked and I can see that data on my screen. Right? So I think it is clear. Now, if I click, just pay attention here. If I click on the model icon here, if you can see a model icon here, it will shift all the data to a different quadrant, that is left side, the second quadrant of the left side. Right? Now your sheet is getting converted into the measures. The entire sheet is like it will fly away and it will get converted into a list of the indicators present here. Right? Now we have to very slowly and smartly shift all these constructs to the screen, working screen. Now this is your working screen. अच्छा बस PLS में एक जो सबसे खराब बात होती है वो ये होती है कि यहाँ पर भी you have all the commands are here and here also you will have all the commands. So you have to decide where you are comfortable. ये जितने आप commands देख रहे हैं, these commands are repetitively present in the software. So unnecessarily it creates a lot of confusion कि हमें कौन सा command कहाँ से use करना है. So it is all up to you from where you want to start working on the PLS. First thing is you have to shift the indicators completely on the working screen. जितने वेरिएबल्स में आपके स्टेटमेंट हैं सभी को साथ में सिलेक्ट करके आप सेटल करिएगा. अगर आपने एक भी स्टेटमेंट छोड़ दिया तो आपका वेरिएबल इनकम्प्लीट होगा. फॉर एग्जांपल आई एम जस्ट डिलीटिंग इट अगेन. मान लेते हैं कि मैंने गलती से 2 ही सिलेक्ट करे हैं, तो ये 2 ही आगे जाएंगे, बाकी का एक वहीं रह जाएगा और आपका जो इवैल्यूएशन है, आपका जो एनालिसिस है वो गलत हो जाएगा. सो बी केयरफुल व्हाइल यू सिलेक्ट द कंस्ट्रक्ट हियर. Select the entire construct. And I said it is a very, very user friendly. It is just a drag and drop kind of a system. So here, social media influence is SI, and there are 3 factors or 3 statements. In particular, this research workshop, I have not used any factor here. I've used a construct and the statements directly. Second is social influence के बाद, this is social influence, this is social media influence. Then I don't want to make it more complicated. I will use buying intention. All 5 statements, I'm taking it on the screen. Now, is it easy for everyone to drag and just drop here? Right? And here, this is the select button here. Click on this and you can rename it also. You can rename it. I'm just putting it as a social influence, SI. Okay. Why I'm changing the names, otherwise it will be a lot of confusion to each one of you, that every time you have to go back and see which was latent variable 3 and which was latent variable 2. Somebody was asking the questions about the latent variables. So here you can see what are the latent variables. Here I'm naming it as social media. Please rename all your variables. Immediately you shift them to the working screen. And then the last is buying intentions. Right. Now, next thing is, I think these yellow boxes here, they are creating a lot of, interruption in between. So what we can do is we can shift them to a different side also. So this is just a beautification thing that you can do. When you see this right side panel, it is all for the beautification, right? You can shift them to, up, you can shift them to this side and the downside. When you have more than 3-4 models, you have to adjust on the screen because space is very limited. You have to create a beautiful model also, because presentation wise, it should look very beautiful. So what right now we can do is we can shift them on a different angles, on a different sides, right? So it will not create any problem in understanding now. So I have renamed all the construct present here, latent variables are named here. Now, next thing is to connect. I see I'm not spending more time on the beautification part. You can also change the colors of these models, the default settings of these models, but I will always suggest do not disturb the basic interface of the model. Reason being ये इनकी पहचान है. The moment you put it on any manuscript or any thesis on a thesis, it will be visible to
Sorry.
anybody that you have
Hello.
applied. Yes,
Yes,
sir.
ma'am. Sorry for inconvenience. Try to be in English medium only because we are having,
All right.
you
Oh,
know,
I'm so sorry.
all
I'm
these
so
problems.
sorry.
Yes. Yes.
Yes, yes,
Thank you
yes.
very much.
Sure, sure. All right. So this is what is visible here. Do not try to change the colors and the basic interface of the model because it is the identity of the model and identity of the software. Now that is the next step is to connect the model. So just connect button is there visibly on your screen. It is there on the panel. Connect. The moment all your models are connected to each other or they are connected somehow, it will get converted into a different color. So this is how it will look. Now, you can change. Again, I have said I'm not spending much of time on the beautification part. That can be seen later on also. Our main task is to understand the calculation part. Now it is a reflective model. So we can use the consistent PLS algorithm here, right? Let us see consistent PLS algorithm. Click on the consistent PLS algorithm. Start calculation. I'm not putting any calculation right now. I'm not selecting anything. I've directly started calculating the model. And this is how it has given me the entire calculation in not even less than a second. Now, so the calculation part is very easy. Now, the main important thing that we have to understand from this particular calculation is, first, we are talking about the measurement model. We are talking about the measurement model here. Let us see the construct reliability and validity statistics. Now, if you talk about the Cronbach alpha value, you can see that the all the three statements here, all the three constructs over here are above the threshold value of 0.07, 0.7, right? So we can see that the data is highly reliable, and the questionnaire that is used can be used for next studies also, and it is very much consistent. RHO, we generally do not report that in the manuscript, but yes, composite reliability and the average variance extracted is that we call as AVE also. Composite reliability, again, the threshold value is 0.7. AVE, the threshold value is 0.5. So we can see here that all the values are within the threshold limit. That means the reliability and validity aspect is cleared by the data. Now, it is so easy. You can just click on the Excel format and this data is copied, and you can take this data on any Excel sheet as it is, right? So just you have to just click on the Excel format, and then it will be shifted to the and directly to an Excel. Now, if you want to see the graphs also associated with it, you can see the graphs also associated. If you can see all these bricks, or I'm just calling them as bars, if they are above this line, that means it is above the threshold limit. As I said, it is 0.7. You can see here, it is all green. If you see composite reliability also, it is 0.7 threshold, it is all green. If you see average variance extracted, it is 0.5. Now you don't have to remember what is the threshold limit. PLS is giving you everything in hand, and it is all visible on the screen. You don't have to remember that what is the threshold limit. If the bar is red, that means the construct is below that threshold. So it is now clearly visible right now. Next thing that I'm going to see is the discriminant validity. Please see the lower panel of your screen where we are going to see the discriminant validity. Now, if you see here, these are the average variance extracted AVEs, which should be greater than the squared interconstruct correlation. These are the calculated squared interconstruct correlations. In MOS, you have to calculate. In MOS, you have to calculate the AVEs, the composite reliability, and everything very manually. Whereas in Smart PLS, everything is you get everything cooked. It is in front of you. So this is how you can evaluate the discriminant validity. Now, coming to the loads, because it is a reflective model, we have to see the loads here. And the standard regression weight all should be above 0.5 or the threshold value is 0.7. But if you can see here that the buying intention statement is in red, that means it is below the threshold limit. But there is a citation to this. There is a reference which states that if the 80% values are as per the threshold, we can accept. Because if you see the round off value of 0.6, it is equivalent to 0.7. And same is with the 0.64, it can be considered as 0.7. So this is how the outer loadings can be seen, right? So as of now, right now, I'm just looking at construct reliability. I'm looking at discriminant validity. I'm looking at outer loadings in this particular PLS algorithm, right? Now, going back to the data, going back to the model, right? You can see the lower panel of the left-hand side, and you can change the weights that is visible on your screen. For example, I can use Cronbach alpha value inside the constructs so that I don't have to go back and see what was the alpha value. Directly, I've inserted that alpha value. I can also insert composite reliability instead of Cronbach alpha. Again, that is up to you, right? We can use the relative paths also. We can use the absolute paths also, right? So this is how you can change even the looks of your model and the values that are present inside the model, right? So this is how we can change. Now, this is all about the measurement model. Now going on to the structural equation model. As I said, generally 99.9% I have used bootstrapping. So I continue using bootstrapping. The one advantage that we get in bootstrapping and even in the next bootstrapping is you can increase the subsample size from here. It will assume that the sample is not 500, it is say 2000. I'm just putting it as 2000 so that we have more accurate results in the bootstrapping. Now let's start calculating the bootstrapping result. Now what we are doing here, we are trying to identify the relationship between the constructs. In the structural equation modeling, I am evaluating how much influence two independent constructs have, on the dependent construct. Now, a very simple table is in front of you. You just have to check the p-values here. If the p-values are below the as per the significance level of 5%, we can see that there is a strong influence of there is a strong impact of social influence on buying intention, and there is a strong impact of social media on the buying intention. Now here comes the importance of IPMA. As I said, when both the variables have got similar kind of significance, how will I identify which is more important and which is, say, highly performing? So this is here the IPMA can play a very significant role, right? Right now, I'm not taking up the IPMA analysis because it is an entire session. So I'm just skipping it right now. Right. Now let us see the total effect. Yes. So because we do not have any mediating and moderating relationship, the total effect and the normal outcome remains the same. The moment I'm going to insert any of the independent variable as a mediating variable, I will show you that also right now. Now, I'm just telling you for a say I'm just inserting, one more independent variable as a mediating variable. Say I want to take website attributes because we're talking about online experiences. So let us insert the website attribute. The moment I'm going to insert one more construct here, it will again ask me to connect. Now this is creating a problem to me. So I will shift its alignment. You can align from here. It is a mediating variable. I will tell you how to connect this mediating variable. But the first thing that you're going to do is the renaming of the variable, that is website attribute, right? Now, what I will do is I will just simply try to, remove this. I don't want to check the direct impact of social influence on buying intention. Rather, I will connect social influence to website attribute and website attribute to buying intention. Now here, as I said, mediating variable is within the model. And now I'm going to check the impact of SI on BI via website attribute. Let us just start calculating. Right? So because up till now we were not having any mediating variable, so there was no indirect impact. Now we have one variable as a mediating variable. Now you can see there is something present inside the indirect effect table also. Now we can see here that one second, I will go back. I'm not using the PLS algorithm. I will just simply go on the bootstrapping, and then we will see the impact of the relationship impact of the mediating variable. Yes. Now, see, these are the total effects. If I can check all the independent variables, even including the website attribute, right, on BI, there is a direct impact also. And I want to specifically check the indirect effect, whether the SI is getting influenced in the presence of website attribute. SI is influencing BI in the presence of website attribute. So here also we can see that, yes, there is an indirect impact of website attribute. That means it is playing a good role as a mediating variable, influencing the relationship between SI and BI, right? So this is the mediation effect. If I just simply convert this as a moderating variable, how will I do this? So I'm just removing it here. removing this from here, what will I do is I can simply click on this, right? Add moderating effect. As I said, it is very simple in PLS to identify the moderating effect. Simply add a moderating effect. Now it will ask you, which is your moderating variable? Say I said website attribute is my moderating variable. Which is your independent variable? Social media is my independent variable. And the BI will remain the dependent variable. Just I have to click on OK. So now it has created a moderating effect. That means how much impact SM is having on BI when the website attribute is as acting as a moderating variable. You can change the color from here so that you can identify, because all otherwise will become red. And now here why it is showing red, because we have not connected one variable. Still it is left unconnected. Now it will show the entire model, right? So this is how you can also make a moderating effect model in the PLS. So the moment I paste this model in my thesis or manuscript, it is very visibly understood that there is one moderating effect also present in the paper. So I hope I am clear till here to everybody. If you want me to repeat the entire step, or is it okay? I'm just removing this moderating variable right now. Even I'm removing this WhatsApp attribute right now. Okay. So as I've already calculated, I'm just going back on the bootstrapping, calculating again, so that I can just share the basic statistics of your relationships. So I think I've already shared that the p-values, there is no indirect effect, only the direct effects are visible. So this is how the impact of one variable can be checked over another. Now, going back to the PPT right now. And in the same, when I say you can change the interface of your model, you can use the lower left panel of your screen, and you can change what values do you want to insert into these construct. For example, in the inner model, I don't want t values. I want the path coefficient and p values. So I can insert that also, right? Outer model, I can have p values again. I can change and I can use t values. So it is up to me what kind of representation I want of my statistics. So that again, what kind of tables you're putting in the manuscript, that you have to decide. And then you can apply both also, weights also and load also, and the p values also. This is how you can change the entire, even if you want to show the effect which is having the more impact, which is having the absolute values. So you can see here that the model, the interface changes here. Right. I'm just stopping this share particularly. And before I stop, I will tell you again that the same functions are present here also. You can save the file, you can create a new project, you can edit your project from here, you can delete, you can select, right? And then you can also change the themes, but I suggest don't do that. And here also there are a number of panels, right? And the right side panel is for the beautification, I'm repeating. So this is how you can use the entire initial Smart PLS software. Right. I'm just skipping from here. Going back to the PPT now. I will just take more 5 minutes to wrap up the session now, so that we can just understand how to cite these, how to use these tables again. Yes. Right. So going back, revising it again, we have seen how we can use the construct reliability and putting it on the full screen mode. Okay. So we have seen how to make a CSV. Then we have added a new project here. Then we have added data in the new project using that same old CSV. How we have imported that data using a double click on the model. And then we have checked the basic missing values and mean, median, and then we have connected the entire model. And then we have started using consistent PLS algorithm for checking the measurement model. We have seen bootstrapping, checking the relationship between independent and the dependent ones. Confirmatory tetrad analysis, still it is left, right? I will try to finish it in case we have more time. IPMA analysis, it cannot be covered in this particular session because we need a lot of time at least 30 minutes to understand what is IPMA analysis. And finally, I have shown you the basic usage of PLS. You can start writing paper using just two steps. One is consistent PLS algorithm and second is bootstrapping. And you can create a good paper using these two steps, right? So I've already shared when to use what. Here, this is a slide which will show you what categories you should click and what is more important. Construct reliability and validity is important. You have to use this. Then discriminant validity is very important. We have to put this in the manuscript every time. Whenever you make a paper, after reliability and validity, the reviewer will always ask for what was the discriminant validity. And then the outer loadings, because I will tell you just in next few slides why these three things are outer loadings and these three things are important. This we have already seen how Cronbach alpha should be above 0.7, then composite reliability should be above 0.7, and the standard regression weight should be above than 0.5. Discriminant validity, all the AVEs, these diagonals, jitne bhi aap, how many diagonals, whatever diagonal things that you see in the table, they are the AVEs. They are the average that extended. So that is that you have to calculate, and otherwise in the MOS, otherwise in PLS it is already calculated, and that you have to compare with the standard, the squared interconstruct correlation. So this is how you can compare SICs with the AVEs, average variance extracted, and ensure that all the AVEs should be greater than the SICs. That is, the AVE should be always greater than the SIEs mentioned below it. So this is how you establish the discriminant validity. Now, next, I have as said, outer loadings are very important, because in case your outer loading is not as per the threshold, you have to drop that statement. And the moment you drop that statement, your model will improve. The relationship will improve of independent and dependent. So here, the loadings are very important. Then R square values, which shows the contribution of independent over dependent. Adjusted R square, when you have more than multiple variables, then you can use adjusted R square. And the model fit values, wherein you can see that the in Smart PLS, the saturated model and the estimated model is already there. It will show you when the model is not having the fit, it will automatically tell you that the model does not fit, and it will not even work sometimes. Sometimes if the data is not correct, it is not present in the correct format, the model will not run at all. So you have to just be careful with the CSV file and the entire, authenticity of the data. Because sometimes what we do is we copy paste the data. We collect the data for one variable and we keep on pasting it on the other variables. So in that case, it will create an identity matrix. And the moment it creates an identity matrix, it will say the software cannot run. So that you have to be very careful. You must have a authentic data with you. In case there is an outline, and I've already shared how you can improve the quality of the data. And these are the explanatory powers. When your R square value is 25%, we can say there is a weak relationship. It is 50%, it is a moderate. And whenever your R square values are above 75%, we say there is a strong relationship or the strong impact of independent constructs over dependent constructs. Hypothesis testing, we have all seen the effects, and we have also seen the indirect effects also. So this is how the p-values looks. We have already seen that in the actual software, so we need not to pay attention right now. And these are the basic literature that you can always support. Construct reliability is Convex alpha reliability is supported by Nanelli 1978. It is one of the most commonly used citation reference to support your alpha reliability. And then I said why AVE, standard regression weight, and composite reliability we study, because these three things come together and they form the construct validity. So other things you can skip, but standard regression weight has to be there, average variance extracted has to be there, and composite reliability that is already present in the table you have to take, and you have when you collaborate them, you combine, make a table, and you find that all the values are as per the threshold limit, then you say that construct validity is established. Then we can see the content validity. Content validity has nothing to do with the statistics. You take the help of literature, you take the help of experts, and then you can establish the content validity. And discriminant validity, I've already said, AVE should be greater than SICs, and there is again a citation to it. Frontal-Darker criterion is there, which you can use. And finally, you have nomological validity. Nomological validity is again a theoretical part wherein the findings should be supported, as well as the studies which do not support the finding. Both kind of studies should be present in your final discussion, right? So when you have 10 studies say supporting your findings and 5 studies not supporting your content, then you can say that the nomological validity is established. Right. So this is the calculation part. You need not to go into the calculation because PLS is smart. PLS is actually very smart. It will give you all the statistics beforehand. But I have included certain formulas. If anybody is interested into it, they can go with the formula and they can calculate it. I have given all the formulas for, but again, this is important when you use MOS because these are the references that I've given. Whenever you're writing a manuscript, you can pick up these references and you can use directly on your reference list. But you must support using these references. For example, common method biasness. A study which says it has to be below 50%. So this is a Podaskov study says that the common method biasness percentage should be below 50%. Thank you so much. This is all from my side. In case you have any query, you can just ask or put that in the chat board, in the chat.
Thank you so much, ma'am, for this insightful your presentation. Now we open the floor for the questions. Participants, please you can raise your hand or you can use the chat box. Ma'am, there is a query from Nega Eju Terefa that what if I have purely quantitative variables such as GDP, saving external debt and inequality, Smart PLS or Stata, which one is good to handle mediating and moderating effects when we have secondary data and pure quantitative continuous variables?
See, when you are using a smart PLS, you need to have the metric data. That means it has to be on a scale. So for that purpose, you need to have some other software. PLS is handling only the metric data. So we cannot have such kind of data in the PLS. You need to have a scale data using a PLS. That is like Likert kind of scale you have to use.
Okay. Then ma'am Shilpi Saxena ma'am has some query. Ma'am, you have raised your hand. Can you please ask your question? Or shall I read it from the chat box?
Ma'am, I just want that you just briefly revise the inner model, outer model, and the difference between weights and loads.
All right. Give me just a minute. I will just reload the PPT here. Yes. See, you wanted to know the measurement model? You wanted to know the inner. See, this is the outer model. When you calculate the statistics related to the statements, they are known as outer models. Generally, we take care of loads over here, right? And when we study the relationship between the construct, what is the impact of one variable, one construct over another, that becomes a structural or the inner model, right? Or you can just simply look at the model and you can see that the statements are falling outside, it is outer model. The construct they are falling inside the model, it is inner model, right? So this is how you can bifurcate between measurement model and the structural model. For measurement model, we have applied the consistent PLS algorithm, and for the inner model or the structural model, we have applied the bootstrapping. So this is the biggest bifurcation of these models. Now, coming to the loads and outer weights. So when you have a reflective model here, I have also mentioned that below the slide. One second, I'll just put it here. When you have a reflective construct, try to read only the outer loads. your standard gradation weights will be known as outer loads. The concept will remain same, but only the vocabulary we are changing here. Formative construct, in this case, we have the outer weights. Now you have to go back and revise what is a reflective model and what is a formative model. All right?
Okay, ma'am. Thank you so much.
All right.
Any other questions from any of the participants? Okay. I request all the participants to please switch on your camera for a group photo. I request all the participants. Ma'am, please can you just stop here? Thank you, ma'am. I request all the participants to please switch on your camera